So, so recording started. Very good. So, welcome everyone to the October Compute Accelerator Forum. I don't have slides for you. I just have very few points I wanted to inform you about concerning the news. So for the next two meetings, the agendas are there. So in 10 November, we will have two talks which are concentrating on FPGAs. One is from LHCb, Giovanni Punzi will talk about reconstruction with FPGAs. And the other one will be given by Thomas Owen James, and he will talk about machine learning inference acceleration with FPGAs from CMS. And then for the December edition on the 8th of December, we also have two talks. One will be given on VecMem. So this is coming from our Atlas colleagues, if I understand correctly. And this is an abstraction layer for data structures, to my knowledge. And the other one, we have been contacted by the APP group of the Beams department at CERN, and they are doing simulation using GPUs, and they will talk about their developments that they have been done for GPUs for simulation in Beams, and also about their usage of actually they are a big user of the CERN IT GPU infrastructure where they're running all the batch jobs. So they will also report about how they are using this. And this will be given by Riccardo De Maria and Giovanni Diadarola. The last thing I wanted to tell you is that, for next year, we are thinking about looking now. I mean, last year we had a lot of talks about from all the various abstraction layers. So one idea would be now that various projects have been looking into these abstraction layers, to invite those and to report about their usage, and maybe even if they have tried different abstraction layers, to come with the reports and maybe a possibility also to compare those. So we are working into this direction. And as usual, please, if you have any other suggestions or you would like yourself to come with a presentation, please contact the organizers of the Compute Accelerator Forum. And the last thing I wanted to tell you is that as we're going already into 22, the dates for 22 have been already added to the Indico agenda. So we stay with the usual slot, the second Wednesday of the month, 4:30. So I talked enough. So I would invite for today we have two talks. One will be given by Ricardo Rocha from ITCM, CERN ITCM, and he will update us on the latest changes in the CERN IT GPU infrastructure. And the second talk will be given by Antonio Paolo, and he will talk about he attended the Nvidia GTC conference, and he will give us a summary of the conference. So Ricardo, are you ready to share your screen?
Yep. Give me a second. All right. Okay. You should see my screen.
Yep. Not in full screen yet.
Click here. Should be better.
Yes, perfect. Okay, please go ahead.
Awesome. Okay, so thanks again for giving the opportunity to give you an update on the availability of GPUs in CERN IT. So I think the last update I've done in this group was in February. I'll try to cover a bit what is available for those that are not aware yet, and then I'll mention what has been updated and what's new. So a quick reminder, if you want to have a look at what's available regarding GPUs in CERN IT, there's this documentation that I link here. You can see there that there's a possibility to use GPUs in different modes. So we offer on the resources themselves at the level of virtual machines, but we also do integration with other services like the batch system, HC Condor, and also the Kubernetes clusters. You can spawn them and we will manage the GPUs for you. And also higher level services that build on these services. So we actually have now GPUs on LX Plus, I'll mention in a bit. GitLab CI runners that offer GPUs, Swan for notebooks with GPUs, and there's a couple of others coming. So if you want a GPU, if you're not using these high-level services and you want a GPU, you can make a request using this dedicated functional element in ServiceNow. Just open a ticket and we'll handle it. If you have any question, inquiry about any topic regarding GPUs, and specifically about accessing GPUs in CERN IT, we have also a GPU channel on the Mattermost of the CERN IT department. So when you ask for a GPU, I'll just do a quick reminder. We ask you a couple of questions. The first one is, what's the pattern that you expect for your workload? This will kind of help us decide if you can use virtual GPUs or not, and what's the requirement for your workload. Of course, if you need some sort of special performance like double precision, we allow you to indicate that, the interface you want to use for accessing GPUs. The OpenStack project name in case you need VMs or Kubernetes. If you care about CUDA drivers, specific versions or custom drivers, and if you intend to do machine learning with some specific framework. Another thing we mention here is if you want to do machine learning and you want to do distributed learning, we can also do some things here. So you can specify that. And then you have a free field to put any other information you think it's relevant. Hopefully this will give us enough information to then understand what's your use case. In general, the requests for GPU access come at a pretty steady pace. They come from the IT department, but actually mostly from outside the IT department, and I'll give an overview. For many of the requests, we forward them to other services where we can do more easily shared GPU access. In general, in terms of assignment of GPUs, we are always full. What we try to do to be able to allow everyone to get a GPU is we try to make the allocations kind of limited in time when possible, so that we can then move the GPUs along. One of the challenges we have is that we often have requests for tutorials where we need to shift GPUs around. And because we are always pretty much full in terms of assignment, this is not very easy. What we do very often is move them around between the services that this high-level services like batch or notebooks or something similar. But but in general, if you have a request ongoing and we still didn't give you the GPU, is because we're trying to get GPUs to be able to assign them. We actually made a reshuffle of the GPUs recently, so if you have waiting requests, it's possible that still this week you will get a GPU. We had a few freed last week. So an overview of how our users are asking for GPUs. You can see here the set of projects that are using GPUs in CERN IT. So it's quite diverse, I would say. You have things like the GitLab CI and LX Plus, where it's kind of dedicated GPUs, same for batch. But you can see that we have quite a lot of other groups asking for GPUs for many different purposes, engineering, machine learning, simulation. There's quite a lot of variation here. Then I tried to do an overview, like some sort of separation of what these GPUs are used for, and it's quite interesting. Like this is not like very accurate necessarily, but in general we can see that half of them are for machine learning and the other half is for other types of workloads. It could be that a lot of this other is also some sort of machine learning usage, but in general it might be completely different things. The other interesting part is how much of these workloads require dedicated GPUs. So in terms of like in terms of the ways we assign them, this would mean PCI pass-through with a dedicated GPU for the service or the virtual machine, or if they can actually survive with sharing GPUs. This is important for us to decide how much we put in virtual GPUs and how much we put in dedicated PCI pass-through. You can see also here below the distribution of the different flavors we offer, basically T4s and V100s, and then vGPUs. I'll mention a bit more why this is still quite low. We want to increase that. So since last February, we had two action items. One was to add GPUs on LX Plus. This is now done. You can access them in LX Plus -GPU. Again, this is a shared GPU, so we would welcome feedback on how you're using it and what kind of problems you see when using GPUs in this mode. The other thing we've added is the GPUs on the GitLab CI. So there are in the CERN GitLab continuous integration, there are shared runners that have GPUs behind that you can use to build your code or validate something, do some functional testing. Other items, Swan also has an instance with GPUs. This is also done. And then we also allow having GPUs on bare metal nodes, physical machines. This can be done. The way this is done, though, requires an explicit request to the CERN IT via a ticket, and we'll handle this. It doesn't take very long, but we do have to do some changes to allow you this to have this, including, for example, a new project where you would have access to this bare metal flavor. All right, so now the good news, we will have new cards arriving early next year, hopefully, all going well. This will be Nvidia A100s. They have very significant performance improvements for machine learning, but actually they also have a feature that will make that will open a lot of possibilities for us, and this is the ability to physically partition each of the cards up to 7 times in different layouts. You can see here on this diagram below how we will be able to partition every individual card in different layouts in terms of memory and compute capacity. This is called Multiinstance GPU, or Mig. Antonio will talk about it in the next talk as well from the last GTC. How we will partition the cards is we will see, but it really will try to map this to the requirements we get. One thing that is, so this is quite flexible. One thing that is important here is actually to repartition or relay out a card, we need to evict all the workloads and kind of reset the card. This is like still pretty good. So you can do this dynamically, but it's still a lot more flexible than what we have today. So we're looking forward to this. In theory, we can imagine that we will have times 7 the number of cards we're about to get, which is quite nice. Each of these individual cards has, depending on the workload, has pretty good performance, including double precision and good isolation with the workloads, of course. But we will validate this further as soon as we get them and publish some results for some of the non-workloads we have. All right, and then the work we are doing right now. So the first thing we started doing is the preparing support in the infrastructure for this multi-instance GPU Mig. In Kubernetes clusters, this is done. There is built-in support for scheduling and assignment of workloads to different partitions. We are working on doing this on OpenStack so that we can do the same for virtual machines and use Mig as well. Then one thing that is kind of related, so before this multi-instance GPU, we already supported virtual GPUs, but this is with T4s and V100, this was not actual physical partitioning, this is time sharing of the card. And we could, for example, with a T4, we could have up to 4 splits of the card, or virtual splits, that would then time share the access. This is quite nice, but there were the usage has been quite limited because of two things. One is the lack of support for profiling, and the other one is the lack of unified memory. The unified memory we could actually work around. The profiling, though, the drivers would not support GPU profile, and this was kind of a stopper for most of the workloads. The good news is that with the new Nvidia drivers, 13X, the 13 version basically, this is possible. So we actually already upgraded. Antonio was doing this. We upgraded the drivers in the GPU in the nodes where we have GPUs in virtual GPU layout, and this has been validated. Profiling works, so we will start assigning vGPU cards for a lot of the workloads, including things like notebooks and similar use cases where virtual GPUs can be used. The other thing we are doing, we are upgrading the drivers in all the recipes. Like in the link I had in the first slide, we had some recipes. We have some recipes for like configuring the drivers if you're launching virtual machines. If you're doing Kubernetes, we do this for you. But in all those cases, we are upgrading the default drivers so that we get support for CUDA 11.1 and 2. This has been a very popular request by many users. If you had your own virtual machine with PCI pass-through, then you were installing your own drivers. You could already do this, but our recipes will now also handle this. And that's actually all I have. And I'm glad to answer any questions.
Great. Thanks a lot, Ricardo. Any questions to Ricardo? Yeah, first one, Attila, please.
Hi, Ricardo. A very well. First off, congratulations to the LX Plus thing. I had no idea that this was in place. Well, so far I just logged in and was very pleased to see that. Hey, it seems to work. About the GitLab CI runners, did something change with the authentication on those? I thought that what you said was that, well, by now they are available to everybody in the wild. Maybe we should follow up afterwards, because apparently something is wrong on my side, because I quickly tried to rerun a test job on one of my existing repositories, but now it tells me that, well, I'm not allowed to run on any runners, even though in the past, while it was in beta mode, that repository was allowed to use the runners. Well, GitLab just tells me like a big "do not enter" sign on all of those runners.
All right, so we can follow. One thing here is that in the previous runners, there were private runners. So there was this documentation where you would need to join a new group and then activate the runners manually. So this is no longer needed. There are just shared runners. So we can have a look. Maybe in the repo, there's some trace of the old runners. But I'm happy to follow up. Yeah.
Okay. Thanks.
Thanks. Any more questions to Ricardo? I maybe have one. Oh, Pere, please.
Yes, thank you, Ricardo. I have a curiosity question. How you manage or how you schedule the different users in the LX Plus instance with GPUs? I mean, are you forcing only one user at the time, or if there are several users, the one that starts running is the one that grabs the CPU, the GPU, and the other will just get an error, or how you do that? So
this is the kind of feedback we need. Like the right now there's no logic there. It's just there. So this was the first step, was just to set up LX Plus with GPUs.
But I guess there is some load balancing, right? Or how many machines are we talking about?
Not many. So this will depend on how popular things get. We can reshuffle things to add more nodes into LX Plus if required. The main issue there is really to make sure that these GPUs are properly used. So we need to understand better how to maintain this service, I guess. As you said, like if the goal is to have a single user per node at each time, and then when they log out, then we kind of free that GPU or something, we can look at that. But there is the possibility like someone logs in and keeps the session forever, and then we kind of hold the GPU if we limit like that. So right now there is no restriction.
Okay, thanks.
No. If you have any feedback, yeah, feel free to send directly or just to drop it in the Mattermost channel as well.
Okay, I see another hand from Charles.
Hi, are there any plans to get any non-Nvidia GPUs?
Not right now. We are following the evolution of things. We don't have any concrete plan to get any non-Nvidia cards for now.
Well, Charles, not publicly, but we can follow up about that.
Well, I actually want publicly so that, different groups can experiment with portability issues.
Okay, then yeah, no.
But like if you, I would say like we actually don't have any explicit request for this. So one thing that you could do, if this is like a requirement, because honestly the look for these cards has been mostly in terms of like having some sort of competitive vendor in-house so that we don't do any kind of lock-in in the end. But it's been more from the infrastructure side. I would say like if you really have requirements to have non-NVIDIA cards, the best would probably be to open a request using this link here in this functional element, and this will make us like follow it up more like properly, and maybe get a couple of cards.
All right. I think it's one of these things where if you build it, they will come. If people see that there are AMD or Intel cards, and they will want to try using them. Whereas I don't think very many people have specific requirements right now to use them.
Right.
People have them in their own little desktops to do their own tests, but as usage increases, I think it'd probably be best to be ahead of the curve and get a few of at least the AMD cards.
Yeah,
I was about to say that it's really just the AMD cards that we're talking about, because Intel cards are not available yet. And this is what I meant, that publicly they will not be available for a while to come.
Yeah, but look, I still think like it would be worth to open a request here and just mention something. This will make it easier for us as well to get a few of those cards. One thing I would mention is that when I mentioned here the service is available. So in addition to this, we have this integration with some public cloud resources where we make more GPUs available via the public cloud. And there's something interesting there, because I did have a hope to include AMD cards using public cloud resources. And this would be like ideal because as you said, like there's not enough requests right now to have them on premises necessarily, but maybe if they would be there, the request, the need would grow. But there is no public cloud provider actually offering AMD cards. They are all NVIDIA, as far as I understand. I went through all the vendors, Azure, AWS, and Google, and it's all NVIDIA. So that would have been a really good opportunity to expose them to.
That's super interesting. I have to admit, I never even tried, but yeah, I didn't even check. Does AMD itself have any way, any cloud that would be available for free just to try things out? So I don't even know.
I have not come across it.
Yeah, we had one company that offered us to like, we can have some resources for you, but then it's not like a public cloud where you have an account and just make use using an API of resources. It would be like some custom deployment that we will have to handle, and this is less interesting. Like the opportunity here for the public cloud is really like, okay, give me this type of resources, I will try it out, and then I forget about it, and I have a nice API that I don't have to commit a lot of time to handle that. So we did integration with all the 3 public cloud vendors, but yeah, for now, none of them has AMD cards. I've sent some emails to Google at least to see if they had plans, and there was no plan, which is curious.
I must say, with another hat on, we would also be interested in using AMD cards, especially for the work towards abstraction layers. I mean, just to see functionally things are working for your super performance system.
Okay,
it is sort of interesting that the only AMD card that I have access to is one that I bought with my own money at this point, because everywhere else it's something else.
Okay.
Intel is a little bit better, but AMD, yeah.
Okay, I'll take this as an action item to see how we can handle this, either like adding on premises a couple of cards or like pushing some public cloud vendors. The public cloud providers, they sometimes have resources that they don't announce publicly that we can get hold of. So I'll recontact them all to see if I can get something, and I'll ping you.
Perfect, thanks. Okay, so Charles, I guess your hand is still up from before. Or you have another question?
Nope, sorry, I'll take it down.
Okay, okay. Good. Okay, any more questions to Ricardo? No, I mean, just out of curiosity, when I log on to LX Plus GPU, is there only one type of GPUs connected to those? Okay.
It's all T4s.
T4s, okay.
For now, yeah.
Okay, so if there are no more questions, then thanks a lot, Ricardo.
Thank
you
you
very much.
Yeah.
And we move to the second talk of today. And Antonio, you're sharing already? Perfect. So the floor is yours. Please.
Hey. Okay, I think everything is fine. So hello, everyone. I'm really glad to be talking to you guys today. I'm going to be presenting an overview of the Nvidia GPU Technology Conference. Just a few words about myself. I'm working with Ricardo in the cloud team right now. I did my master's in computer engineering, and I actually started at CERN in 2019 in the Tech Lab project, and I was working with GPUs, but also with some power CPUs from IBM, and also ARM CPUs, and a bit of Xilinx FPGAs, so I really like hardware. Anyway, a bit of a presentation overview right here. The GTC, I'm gonna begin talking about what was GTC April 2021. Also, who cares about it, highlights, and trends. So what was GTC21? It was the second GTC that happened virtually. The first one was 2020. It was a 2-week event, although the bulk happened during the first week of April. I mean, from the 12th to the 16th of April. And in the second week of the event, there were much less talks. There were also some hands-on sessions, and just some context. The first GTC was in 2009, and it used to be once a year. But actually, this year they will do another one in November, so it's pretty close. And I think this presentation fits well into motivating in case you want to attend. Also, it used to be physical. So who cares about GTC? This is just stock price from Nvidia during the first week. And usually innovation does drive up stock prices. And there were many people watching. I think in 2020 at least, there were at least 60,000 registrants. And we can see that it really increased the stock price. So there are many people watching. Some highlights. This is an overview of what I will be talking about. So some cool stuff. It's the Omniverse, just basically a digital universe. Also autonomous vehicles. Then I'll be covering some hardware. They announced their ARM CPU, which is called Grace. They also kind of announced the Bluefield 3 DPU, the data processing unit. Jetson, which is their embedded systems line. Also, their new DGX, EGX systems, which are just basically their enclosures with the Nvidia GPUs. They announced the A30s and A10s in the event. And I'm not going to cover it in this talk, but they have a lot of software that they talk about during all the event. So I'm just going to read it out loud because I think it's nice to have an idea of what they're working on. And they announced their pre-trained models, which you can get in the Nvidia GPU catalog. Also, a lot of different kind of software. Their Megatron Triton giant transformers, inference, Q-Quantum for quantum computing, Clara drug discovery. This is for medical applications. They also have a conversational AI and the recommender system. Both one of them called Jarvis and the other Merlin, and also the Maxine virtual conferencing and Morpheus AI security. So let's start off with talking about Omniverse. Essentially, it is described as a digital collaborative world. And I really think the best way to understand it is to take a look at their BMW factory example, which is basically they clone their entire factory into a digital universe. And this allows them, for example, to train robots in this Omniverse and then deploy them IRL already trained. And this also allows them to plan and simulate factories. Also, in this Omniverse, you have digital humans that can be used for simulation that are pre-trained. And it's really interesting. I enjoyed learning about this. So there's a short video linked here if you want to check it out. Now going into autonomous vehicles, this has been presented throughout the years in previous GTCs as well. The point that I want to make here mostly is just that NVIDIA is focusing in the entire stack. You can see that, let me just get a pen. So you can see that they want to provide you what you put inside the car, what you use to design the car, what you use to simulate the car experience in the road, and also the training platform. This is just to talk about that the vision is that the car is no longer just a product on itself, but also the software that comes with it. And here is a car schematic just showing that NVIDIA wants you to have their Orin computers inside, also the sensors and all of that. So now going onto the ARM Grace CPU, NVIDIA starts by presenting this as saying that there is a bottleneck, which is true. Eventually you'll get bottlenecked by the PCI interface. And their solution to this is to develop a CPU, ARM CPU. I guess they are trying to acquire ARM as well, so it plays well into their end. But they want to solve it by having this gray CPU, and very generally, this is still very broad and abstract. But you have their CPU, which is connected to some memory modules, and it is then connected to the GPU. This is a render, just to have an idea. Who knows how it will actually be. Here you can see just the memory modules on the top of the CPU, and they announced that it should be 300 spec-int, and you see that it should be connected to the GPU very closely, which obviously is advantageous. They also announced that they will have the Alps supercomputer in Switzerland, predicted to be available in 2023. And they did mention that it would be helping in quantum physics for the LHC, although I don't know a lot of details about this. They also mentioned that it would work in weather, climate, and material science. So they focused a lot on ARM, and they showed this slide during the keynote, at least, where they present what they're working on in ARM, and this really shows out their positioning. So they want to have the Amazon Web Services Graviton ARM CPU integrated with NVIDIA GPUs in the second half of 2021. I haven't checked how much this as actually how it is right now. Also integrating with the Ampere Ultra ARM CPU, Ampere, not the architecture from Nvidia, but the CPU. And they also mentioned their Bluefield DPU, which is also based on ARM cores. Here you then, for the Edge and Enterprise, again, some more ARM CPUs integrated. And for PC, they want to have MediaTek ARM CPUs working. This is mostly to play games or any other visual stuff. And right here, they show a Quake 2 demo. But in July, they already had a tech demo where they showed Wolfenstein 2 running in a MediaTek chip. So I guess they're having progress. Now going on to their Bluefield DPU, a data processing unit. This all comes from their recent Mellanox acquisition. These DPUs are used to offload tasks from the host server CPU, and they can do things like interfacing with storage device, or security checking, or network data transmission, and also communicating with GPU. These DPUs can think that what they're meant to do is basically provide a divide between the infrastructure logic and what, for example, users are doing in their VMs. Their Jetson line is what they announce for embedded and edge computing. These can be small, these are small and low TDP portable machines. Imagine that you want to do inference in drones, for example, while you're capturing some images. This is a roadmap to have an idea for what they're thinking. I guess with a gap of two or 3 years, they want to have big launches, but they want to have something new out every year. Here we can see the GPUs, Ampere next, and the CPUs, Grace, potentially coming 2023, and also the advancement of their Bluefield DPUs. Talking about the DGX systems, this is the enclosures that they provide already with Nvidia GPUs. This is one of the examples. It should cost about 200K. It should come with the AMD ROM CPUs, 2 of them, and also 8 Nvidia A100 CPUs and GPUs connected with NV switches. This is, well, usually they are kind of taking away or competing at least with the other OEMs, you know, typically Dell or HP or Supermicro, which is an interesting move. They announced their A30s and A10 GPUs. For the A30s, which you can see here, it also allows for Mig, multi-instance GPU instances, which Ricardo previously talked about, but I'll also cover it a bit more. And the A10 is, it is positioned more for virtual workstations. So it also does, it wouldn't, you would go for the A30 if you wanted FP64 workloads, basically. So talking about multi-instance GPU Mig, it does allow for a better separation than vGPUs, for example. You have you know, you have video memory and also the bandwidth allocated. So you have you can expect the latency and performance of whatever you're doing to be more or less always the same. This is this graph on the right. It is just a comparison between running Mig in bare metal or a bit virtualized, and they show that the difference should be more or less the same. These Mig instances are available for bare metal, but you can also do a pass-through of an entire GPU, as we already do in our cloud infrastructure, and then inside that VM you can create Mig instances. Also, you can have let's say, a Mig instance enclosed inside a vGPU instance, which could allow you for more monitoring, for example. An interesting topic is GPU Direct RDMA. This is remote direct memory access. Just, I guess the main takeaway here is that instead of having to also go to the CPU, you can have a direct communication from the network interface card to the GPU. This is the main takeaway. And a bit like this, you can also have this with storage. This is a NVMe drive. Instead of having to go to the CPU, you would just go directly to storage and simplify the communication. Now on to the section about general trends. So you see AI everywhere. They really like using the word AI. I guess this is normal. I saw tons of AI for medical applications. MLOps is a thing. I will cover this. There was a big push for vGPUs with a lot of sessions. They also pushed their Deep Learning Institute and their Nvidia GPU Cloud catalog platform. There were a lot of Kubernetes talks as well. Also a lot of 5G, which they call the Nvidia Aerial for telecommunication, for example. And there was some talk on GPU profiling and benchmarking, though I'm not really going to cover that. MLOps is like DevOps, but for machine learning. You want to let the data scientists focus on the data science while you provide them with the means to build machine learning workflows in a simple way. Kubeflow is one of the platforms that you can use to do this, and that we actually also deployed in our cloud infrastructure. And just searching for MLOps, which was a term I wasn't familiar with at the time, I found 58 results, so it was really present. Common use cases for MLOps are you want your user the user wants to build something really fast, so you can present him with a notebook, or just he wants to train his model as usual, and you can also provide things like hyperparameter optimization, or eventually serving this model, so putting the model into production. They presented something which was the Triton inference server. I found that it could be promising. It can be deployed using Kubernetes and also Mig. It supports both CPUs and GPUs. They try to maximize resource usage with it. And also something interesting would be concurrently serving multiple models on a single GPU. This relies on CUDA streams. It supports major frameworks such as TensorFlow, TensorRT, PyTorch, and Avionics runtime. And it also supports Google Cloud and AWS if you don't want to deploy it in your own thing, in your cloud. Here are some vGPU sessions just to show that they were really present. These are what they said were the recommended for virtualization, but as long as it's supported, you should be able to do vGPUs. This isn't really very important, but if you want to check out the specs, here they are. Some notes on vGPUs. So they do enable GPU partitioning, which like Mig, they provide you with a virtualization layer so you can do monitoring, and they also provide you with a bit more security guarantees, because if you're doing PCI pass-through of GPUs, I mean, if the user could theoretically flash the vBIOS. Some other points is that their major VPU releases should come out every 6 months and minor every 3 months. And it's actually nice to keep up with these releases, just because, for example, the profiling support was just launched very recently. So it's nice to know more or less the cadence of their releases. There's a big focus on VMware Sphere, no doubt, Citrix, but also RHEL ecosystems for vGPUs. This slide here is more to illustrate that you can interact with the people from NVIDIA while you are watching a talk. And so talking about the GTC Online platform, I actually found it pretty great. You do have live chat to interact with the people that are presenting, although they are presenting, it depends, but it can be live or recorded. You also have private chat rooms in some cases where you can go to talk with the NVIDIA representative if you are really interested in something. It was nice to be able to go backwards even when live, instead of having to always be there. When you get the replay, you can go up to 2 times speed, and this is nice. I also like this feature. You can have you can control the video with some keybinds, like speeding up or speeding down whenever you need to. It's nice to have these small things. And the slides are usually always available in the same page of the event that you're attending. Also, they have the add to calendar feature available, which I also find useful. Talking about the DLI, their Deep Learning Institute, it seems okay. I attended some of the hands-on sessions when basically it was a Jupyter Lab instance. So you have a notebook connected to GPUs. You do have the instructor materials available, which is nice. I found the courses that I attended okay. And in case you're interested, they actually did a talk just on this. You can be a DLI ambassador. So you travel the world teaching NVIDIA GPU stuff to people. This is the NGC, the NVIDIA GPU Cloud Catalog. This is where you can get images for NVIDIA software or also their pre-trained models. Some miscellaneous notes is that they finally allowed GPU press-through of GeForce cards for Windows VMs on Linux. This isn't very interesting in our use case, but I know that the community was asking for this for a while. There were some nice introductory talks if you don't know about a specific subject. For example, I linked to here how GPU computing works. This one was actually pretty fun. And machine learning inference demystified. They also have some others on this demystified series, like deep learning demystified, things like that. Also, the next GTC will be pretty soon. It will start on the 8th of November. I'm leaving here some useful links. The talks are available in their on-demand platform. And I also left the homepage here. If you want a very quick, brief overview of the event, we have a 3-minute highlights video linked here as well. If you're interested in their Ampere GPU architecture, they have a nice blog post about it, and also the link for the next GTC. So in conclusion, NVIDIA wants to control the whole stack, and this is obviously beneficial for them, but it is also sometimes the only way that they have to be able to attract and retain customers. They never missed the opportunity to use the word AI. If you count them, they were really a lot. And yeah, I'm ending in interrogation note, I guess. Is the lock-in real? NVIDIA does give signs of opening up. For example, a Triton inference server is available in GitHub. But licenses cost, for example, for vGPUs can go up for all we know, and it can start being unbearable. And yeah, this was it. Any questions, please do let me know.
Thank you very much, Antonio. Very nice talk.
No problem. Thank you.
Okay, any questions to Antonio? Yes, Charles, please.
So I'm not sure if this was actually mentioned during the presentation or not, but while we're on the subject of new NVIDIA projects, I think it's very much worth mentioning the NVHPC software stack, which includes the NV C++ compiler. And I think this is very, very interesting because it actually has an implementation of the STD execution parallel and parallel unseek that will allow you to run STD execution code on a GPU. And they basically have I know it's quite the only implementation, but it's certainly the best implementation right now. And I think this is something that's really worth experimenting with for an easy way for developers to access the GPUs right now.
Yeah,
And if
I can
people are
see
interested, they have a lot of documentation online.
that. Yeah, definitely. Thanks for sharing. I don't think I remember them talking about this, but or at least focusing on this topic. That's always nice to know.
Okay. Any more? Yeah, Patrick, please.
So the consumer market for GPUs right now is being really badly impacted by the shortage of chips, I guess. The prices are ridiculous. Is that also happening on the commercial side of things?
Yes, I do think it's affecting everyone, but sometimes they have agreements that they have to fulfill, and they will try to do them first with enterprises. Yes, but it's the same everywhere. It's hard, but also because of the demand, not only the shortage. It's just a lot.
Okay, thanks. I have a question which I'm asking myself. I mean, I put a lot of assumptions in my question. First, I mean, I'm interested in double precision performance of GPU cards, because we are porting some event generator, and this mostly runs with double precision. Now, if I understand correctly, Nvidia allows only to run professional cards to be deployed in HPC centers via their software agreements, and all the professional, or most of the professional cards provide the double precision. Now that
I think that you can have professional cards as a consumer. It's more the other way around. You usually can't have consumer cards in HPCs. Usually that's the restriction.
You cannot, or you can?
You cannot have consumer cards in the data centers. Okay.
Yeah.
But usually you can have prosumer cards like the A100s. You could get them.
Yes. No, but in HPC centers, I will only find the professional cards.
Yes.
And those provide me double precision. Now, you are mentioning that everything goes in the direction of AI. Now, for machine learning, for example, you don't need double precision, if I understand correctly. You do single precision calculation or even half precision calculation. Do you see anywhere that this may be, that this could also go into for computing centers, that these cards with only single precision calculation capabilities could be deployed?
Yes, they could. It always depends on the use cases. But when you have double precision capable cards, you do have a lot of better performance when doing those tasks. I'm not sure if that answers.
But Stefan, I imagine that, well, I haven't heard any presentation of Nvidia removing double precision capabilities from their professional cards, but it's not a priority. It's definitely not a priority.
No, but I'm asking myself, if the market goes into the direction of AI, and AI doesn't need double precision, then we could end up in a situation that we want to run on the HPC center. We don't find ourselves with the right cards anymore.
Certainly, they're marketing some cards explicitly for AI. Such, I remember it's the A10 or the A40, which has lots of tensor cores, but no double precision. Mm-hmm. And those are definitely not, your desktop cards. Those are the pro grade cards.
Yes, that's true. Okay. Thanks. Okay. Any more questions, Antonio? No. I don't see any. Okay, so then this concludes this meeting of the Compute Accelerator Forum. Thank you, thanks to our presenters, Ricardo and Antonio, and talk to you again in November, 10th of November.
See you.
Bye.
Bye-bye.